This presentation was prepared as part of the HAB 823 course on Comparative Effectiveness taught by Dr. Farrokh Alemi, PhD at George Mason University, Department of Health Administration and Policy. My name is Donny D, and for this Teach 1, I'll be going over Week 5, Question 5 on causal network regressions. In this question, we want to know how often one disease occurs before another. From this data, we can investigate the temporal order of disease occurrence and identify patterns that can be useful for healthcare decision making. We'll be focusing on patients who had both disease and disregarding patients who had one disease but not the other. For this question, we'll be using Python, and we want to first import the libraries Panda and NumPy. Then we load the dataset diseaseorder.csv provided and select the columns first, next, and count. Initially, you can update data in Excel by removing the spaces in each column to avoid the string error. In this example, I've already updated the columns in Excel and upload into Python. Step 2, we want to calculate the point differentials. The first part of the code defines a dictionary called point_diff with keys as tuples of two diseases and initializes their values to 0. The dictionary excludes pairs where both diseases are the same. The code then loops through each pair of diseases A and B in the point_diff dictionary. We then created a for loop which calculates the count of occurrences where disease A appears before disease B in the dataset under AB count, and the count of occurrences where disease B appears before disease A under BA count. After calculating the point differentials for all pairs of diseases, we enter another loop that iterates through each disease D in the disease list. This then calculates the point of differentials between the current disease D and diseases in the disease list, including M, N, U, and V, excluding itself. For part B, the question is asking which disease occurs first. The disease that occurs first is the disease that has the most negative sum of point differential, which in this case would be disease D with negative 124 sum of point differential. Next, for question C, it's asking to calculate the temporal rank order of the diseases based on their total point differentials with the other diseases. First part of the code, it defines a dictionary called disease_diffs, where the keys are diseases and the values are the sum of point differentials for each disease. The sum of point differentials is calculated by iterating over each disease D in the disease list and summing the point differentials with all other diseases except itself. We then sort the diseases list in descending order based on their total point differential with all other diseases. The sorted function is used with the key parameter that specifies the sorting criterion. In this case, the lambda function, lambda d colon disease_diffs D, is used to retrieve the sum of point differentials for each disease D from the disease diff dictionary. The reverse equals true argument ensures the list is sorted in descending order. In summary, we calculate the sum of point differentials for each disease, sort the diseases in descending order based on their total point differential, and then print the temporal rank of the diseases with their rank numbers. The diseases with the higher point differentials are ranked higher in the temporal order. For question D, it's asking which two diseases are closest in time to each other, which would be the one with the smallest absolute time differential between them. In this code, we use the min function with the key parameter set to point_diff.get, which finds the minimum value from the point_diff dictionary using the values for the comparison. The key equals point_diff.get specifies that the comparison for finding the minimum value should be based on the values of the point_diff dictionary. In other words, it finds the key pair of diseases with the smallest value. The result of the min function is assigned to the variable closest pair, which represents the pair of diseases with the smallest time differential. Finally, it prints the closest pair of diseases based on the time differential by using an F string. In summary, this code finds the pair of diseases with the smallest time differential to find the closest pair. And from this output, the closest pair of disease based on time differential is disease D and M. This is the end of my Teach 1 presentation, and thank you all for watching.